Hey Geometry, welcome to the second section of circles. So we're going to do this one. We're going to look at angles and arcs. By the end of this, you should be able to identify central angles, major arcs, minor arcs, and semicircles, and find their measures. So some vocab. A central angle is an angle whose vertex is on the center of a circle. So for example, if we go down here, AOD, angle AO, that's an O. D is a central angle. The sum of all the central angles, the sum is 360 degrees. So if we add up all the central angles, we get 360 degrees. An arc is a portion of a circle defined by two endpoints. So for instance, we could use arc CE over here. And we use this little, instead of when we had like segment before and line with arrows, we do a little arc symbol, kind of looks like a little rainbow or something, to represent the arc. So if that's one way we could reference an arc. We should use 3 points. So if we're doing like one common type of arc is a semicircle. Because we need to make sure it's clear. If I say from A to E, okay, well, which way, which arc are you talking about? It may matter. It may not matter in some cases, but so that's a half a circle. The arc measure, so that's 180 degrees, and so a way that we could reference this would be arc, and then we can do also from D to C, DAC. We can also have a minor arc, so we only need to use 2 points for this. Is any arc that is smaller than a semicircle, so less than 180 degrees. So for example, we could do the CE there, or we could do AD as well, arc AD on that side. And then we would use 3 points if we're doing a major arc. An arc that is longer than a semicircle, so greater than 100 degrees, and less than 360. At that point, that gets weird. If we go beyond 360, we're not really doing an arc anymore. And so, for example, in this case, we could go from all the way around to D to E, but go the long way. So, for instance, arc DCE would be a major arc around the outside. So, for this example, name the circle. This would be circle O. Kind of looks like a circle there. Name 2 minor arcs. So, for example, we could say arc CE and arc DA or AD. So those are both minor arcs. Name 2 semicircles. So we could say arc AC, or I guess I'll go this way, ADE. We could do that arc. We could also do an arc from, so ADE. We could do an arc from DAC. DAC would be another one. And then name 2 major arcs that aren't, not necessarily semicircles. So yeah, they need to be bigger than that. So we could say, for instance, arc ACD and arc EDC. Going around the long way. Congruent arcs are, congruent arcs have central angles that are the same lengths. So congruent arcs are arcs with central angles that are the same. And then, the measures are the same. The measures are the same, and so then the arc lengths are the same. Therefore, arc lengths are the same, and vice versa. And then adjacent arcs are arcs on the same circle that have exactly 1 point in common. Those adjacent arcs on the same circle that have exactly 1 point in common. So arc measure of a minor arc is equal to the measure of its corresponding central angle. The measure of a major arc is 360 minus the measure of the minor arc related to it. So it's kind of just the proportion of 360 degrees that angle measure for that. So for some examples, find the measure of each arc. Arc BD, all right, that minor arc. So if this is 58, this is also 58 degrees. And so we can add those two together and get a 90-degree arc for that one. So it's 32 plus 58. We have those two, you see those adjacent arcs, these adjacent angles. So 32 plus 58 is 90. Arc ABC goes around here, and so they don't tell us what this is, but we do know that this is a straight line, and so we know that that is 180 degrees. So it's that arc is a part of half a circle there. Arc AB right there we could figure out, so we know that that is 180 minus 32. From the 180 we knew before, and so that would leave us with 148. And arc DAB, DAB all the way around here, we can basically do 360 minus the 90 we know in there, or the 32 and the 58 together, but it's 360 minus 90, which leaves us with a 270-degree arc all the way around there. So you can try these on your own, or pause and then see how you do, or do them along with me. Arc SQP, so SQP, that is 180 degrees. That's our semicircle. Arc RS, well, we don't know what that is, but we know that this is 180 degrees. So if we do 180 minus 77 gives us 103 degrees for that one. Arc QRP, QRP going this way. So if this is 28 degrees, we know that's 28. You can kind of work on the inside or the outsides. I tend to, prefer the inside. So we know that this is 180, and then we're going to add on another 28 to it. So QRP is 180 plus 28 more, gets us up to 108. And then arc PQR goes all the way around. It's everything but the 77, so 360 minus 77, and that'll leave us with 283 degrees for that one. So each of those. The measure of an arc is in degrees, while the arc length is a fraction of the circle's circumference. An arc of 60 degrees represents 60 over 360, or 1/60th of a circle. So the arc length is 1/6 the circumference of the circle. So when you're looking to find arc length, it is going to be, so for instance, length of, and then an arc, I'll say for example AB is going to be equal to the measure of arc AB, which would be the angle A, whatever the center of the circle is, B, divided by 360, and then times 2 pi r. So that's the circumference, and this is the fraction of the circumference that we are going. So determine the length of arc XY. Leave your answer in terms of pi. So we want this length. Well, this is 90 degrees, so we're going to have 90 out of 360, which is 1/4 of, and then we need the circumference. We can do 2 pi r. We could also just do pi d, so 16 pi. And so that ends up being 1/4 of 16, which is just 4 pi. And so that's the answer to that first one. In terms of pi, units would be inches. The next one, XY, we have a 15 centimeter radius. We got a 240 degree, and they're giving us the arc XY, the major arc XY. So first of all, we can figure this out by doing 360 minus 240, which is 120. 120 degrees. And so our fraction of our circle is 120 over 360, which ends up being a third of that circle. And then our radius is 15, so 2 pi times 2 pi r, or you could have done pi d with 30. 2 times pi times 15, so that ends up being 30, but then 1/3 of 30, this ultimately simplifies just to 10 pi, and this is in centimeters. And you can, of course, figure out what that number is by typing into your calculator. So in the future, a sector of a circle is a region bounded by an arc of the circle and the 2 radii to the arc's endpoints. So the sector would be like the piece of pie or the slice of pizza or whatever that you are thinking about there.